Okay, in this video we are going to build a water detector. Now I built one before and I made a video. This is a circuitry I used, a 4093 Schmitt-Trigger NAND gate together with a set of probes. So here's my probes that go into the water to detect the water. So I'll play back a little clip of that video. Okay, now you know how this little water detector circuit works, and you can build your own on a breadboard like this and get it up and running, and the component values aren't that critical. So you can even hook it up to our Arduino Nano and come up with a really fancy alarm system. Now I was approached to build a no-touch water detector, so they didn't want any probes actually touching the water to detect water. So in this video we're going to look into how we could build a touch-free water detector. Okay, so this is my no-touch water detector. So basically I have a square box. One end of the box has an LED, other end of the box you can see down here has a photocell, so there's a light beam across the box. So if I put a glass of water into the box, you see it detects the water. Now if I put an empty glass, it doesn't detect it until I actually pour water in it. And it detects the water. Okay, here's the circuit for my water detector, and I'm using the Arduino Nano. So when pin 13 of the Nano goes high, indicating water, it's detecting water, it will turn on the buzzer. Now I have ADC 0, analog to digital converter 0, monitoring the photocell output. So when a photocell changes resistance, indicating there's water, it triggers pin 13 to go high, which turns on the buzzer. So if I put the glass into the detector, you can see pin 13 comes on, energizing the buzzer, indicating there's water in the glass. Okay, this no-contact water detector uses optics to detect the water. So you can see here we have an LED, that's our light source, and then we have an aperture, and we have a second aperture, and the light source comes through the first aperture and it goes through the water cup. That's the water cup here without any water in it, and it goes through the second aperture to the photocell, and the photocell resistance changes when it sees the light. Now when we add water to the cup, the light source comes through the first aperture and it gets refracted away from the second aperture. So no light or very little light gets out the second aperture to change resistance of the photocell. So the difference in resistance between water and no water is fed into the analog to digital converter of the Arduino Nano, and we could actually have a certain trigger point to detect water. Okay, here's the code running on my Nano for my water detector. So the first thing I do is take the number 500 and I assign it to the value trigger. So that's my trigger point. So anything over 500 indicates water, and anything under 500 indicates no water. So here's my program. It's called water. So the first thing I do is init. That initializes pin 13 as an output. Then I select analog to digital converter A0 on the Nano. Then I go into a begin until loop. Now this is a continuous loop until I hit any key on the keyboard to come out of the loop. So in this loop, it reads the analog to digital converter. That's the photocell. So it's reading the light on the photocell. And it compares it to trigger, which is 500. So it's greater than 500. And pin 13 goes high, turns on the buzzer. And if it's lower than 500, then pin 13 goes low and turns off the buzzer. So this continues in a loop, continuous loop, to detect water. Okay, so now you know how this touch-free water detector works. Now I'm using a microcontroller in my circuit. I'm using a Nano, but you could simplify this circuit and use a voltage comparator. And you could take the voltage from the photocell and feed it into the comparator and set a trip point to trip the speaker when it detects water. But I wanted to use a microcontroller so I could tweak certain things, because you notice when I put the empty glass into the detection box, it got a small beep. That's because the bottom of the glass is thick and it thought there was water in it, so it gave a short beep. So I could fix that with software. So it's the principle of how this works, how you could diffract light through water, and you could use that in other projects that you're building.